Welcome to
KidMath114.
KidMath114. We're back from vacation. We're starting chapter 17 of our Art of Problem Solving Algebra book, and it's about graphing functions. And so today, can you just grab an eraser from behind you? Today we talked about some basics of graphing functions. And so we're just going to do a few problems kind of like we did. Tell me whether what I've drawn is a function or not a function. Sorry. Is this a graph of a function? Or is this not the graph of a function?
Well, this is a graph of a function.
Okay, why?
Because for every point you pick, let's just say this is 5.
All right.
You have one output.
Okay, so here's my graph y equals f of x. And it seems like on this graph, for every input, I have exactly one output. Where does this graph cross the x-axis?
It only crosses it at this point.
Crosses it at that point. Where does it cross the y-axis?
Right here.
Do you remember what those special points are called?
The x and y intercepts.
The x and y intercepts. Okay, very good. Let's do another one. Is this the graph of a function?
No, it's not.
Okay, why not?
Because you have this point right here. Let's just say this is 2.
Okay.
Then the output can either be this point right here or this point.
All right.
You have 2 outputs for one input.
Okay, is that a problem?
Yeah, because every input has one output.
Okay, for it to be a function, every input has to have exactly one output. Okay. All right. Now I'm going to try to do a couple complicated examples here. Okay, now these are supposed to line up on vertical lines here. Okay, do you think this is a function?
Well, you have different ranges for each piece of the function.
Okay.
So like for this piece, you're gonna have x it's just gonna be less than, because the open dot means less than, not less than or equal to, which is less than some number.
Okay, well, what's our definition of a function? How can we tell whether something's a function or not?
If every input has exactly one output.
Okay, that's what we're trying to look at this graph. We're not worried about the domain and range just yet. We're just trying to see if every input has exactly one output.
Well, yeah, it seems like that's going to work.
Okay, now what about on these weird overlapping points?
Well, these overlapping areas, it goes up to the one before it.
Okay, so is this a function?
Yes.
Yeah, it is. If you extend this out forever on both sides, this is an interesting function called the Sawtooth Function, I think is the name of this one. It's an interesting one. Kind of looks like...
So.
Actually, it might not be. Sorry, the Sawtooth Function might actually look something a little different than this. But anyway, this is just a function that goes up and then comes down, up, down, up, down. Okay, it's a perfectly good function. Might not be the Sawtooth Function. I probably shouldn't have said that. Shh. Okay, one last one. Is this a function?
Well, the problem is you've got these points in here that don't have an output.
Right.
But those just aren't part of the domain.
Right.
So, this is a function, because you don't have a part overlapping.
Okay. Very good. The fact that it has a gap in it is exactly what you said. Good job. Those just aren't in the domain. So there we go. There's an interesting introduction to graphing functions in this first section of chapter 17. Pretty cool, right?
Yeah.
And so what's the one important thing that we need to remember about functions to tell if something is a graph of a function or not?
That you can't overlap.
Okay? And how do we say that mathematically?
It has one output, or has one input. It has one output for every input.
Every input has exactly one output. Okay, very good. Good job, hon.